Hey everyone, I'm David Room. Today we are going to be working on some programmatic 3D modeling with Python code, like is usually the subject of our streams. But instead of doing this for game dev or high detail 3D art, we're working on it for a little bit different application. I've had a little side project kind of ever since November or so where I'm trying to take my low poly humans that I'm building for my game and actually take them into the physical world through 3D printing and make retro style action figures. And I've had a couple days off work here, and I'm hoping to cross that line and get a lot of this capability actually up and running with a test character and see this happening in the real world. So I'm just going to show a little bit of what I'm working on here. I recently kind of took the low poly characters from tests into trying to actually make specific characters for my game, even if it's just the start. So I've been working on this character called Livia, uh, giving her some clothes, updated game materials. Um, for the past uh, week or so, I think it was actually last week, I have been working on extending the low poly humans framework to make monster characters. So if you know anything about my setting, it's not a pure sci-fi setting. There's like these kind of demonic interdimensional entities called nomads, and I was creating a nomad character using these same tools that I'm building, and I'm pretty excited about these results. It's neat to see something that's been in your head for a long time come to fruition and kind of become real. And eventually I want to try to make a 3D printer figure of this guy as well. But we're starting with this human character, and I am going to try to make something like vintage Kenner Star Wars action figures, and they have a very simple form of articulation where the head turns, the arms pivot, and the legs pivot. So what we need to do to be able to take this kind of low poly game asset into something that prints is cut out certain areas of the mesh to allow it to pivot. So this is something I was working on Friday, is kind of designing these things. And whenever I design something like this, I'm not manually designing it. I am writing code that designs these shapes. And the neat thing about this is that these shapes are kind of automatically sized to the configuration of the character. So while I'm testing this out for this particular character, theoretically, or with a small amount of modification, it should basically just apply to any other character that I create. So if I create a character that's much taller, a male character, different proportions, these shapes will kind of by default size themselves towards that. Now the step that I'm working on now is I have to actually be able to physically print this, and it's kind of hard to see in these pictures, but this model has a lot of structures that are not actual manifold or watertight meshes that you could print. And also, in order to be able to do this cutting, I need to have a collection of manifold meshes, either meshes that are one watertight surface or a mesh that has a number of connected components that can be separated and then into components that are each watertight surface. So over the last couple days, I've been working on this, and we'll come back to the head in just a second here. Oh, interesting. Interesting. Okay. Um, all right. So, um, the the challenge is uh, turning these models into things that can work with these different things. And interestingly, I just ran into an error here that I wasn't expecting. So I'm curious to see what is going on here. Yeah, so actually I'm just going to disable this. So I'm not sure. Something changed here. And run this again just so we can see the overall model that we're looking at. And whoops. Yeah, okay. Yeah, I don't know what's going on with that particular error, but so here's the model, and you can see that I've fixed a number of these things. So the coat, oh man, my controls all messed up too. The coat now is a solid. The boots are solid. The hands. So mainly what needs to be fixed now is stuff in the head. So there's a number of sort of flat or one-sided meshes in the head area, specifically like the eyebrows and the hair and things like that. And the head itself, I probably have too many structures here to turn on and off and find them in this view. But there's like ears, and then the head itself is like a couple of pieces that put together so they're not watertight. And the next step basically is to just make everything watertight. So I'm gonna tonight be kind of going through the different components of the head. I think first I'm going to take a look at what this error with this union is because that strikes me as odd. I don't know exactly what's going on here. But I'm just going to put on some white bat audio, and we're going to get into it here. I was thinking about calling this video like not vibe coding. It's been some interesting developments in the software world since I've been streaming a lot. I've had this kind of lingering cold for the past couple of months, really. That has made me not really feel like working on streaming. So I think I'm finally getting over it. Okay, yeah, let's figure out what's going on. What am I trying to do here? And why is this union all of a sudden not working? It's this union that's not working, right? Or is it something else? And for anyone who's new, yeah, why would these all be volumes? That's strange. For anyone who's new here, I'm doing all of this with code, right? So when I say, like, I'm going to change these meshes to be manifold or whatever, it's not about, like, manually making edits. I'm building a system that allows me to make these things programmatically. So while there's an element of tweaking things and you know, individual cases. In general, I'm trying to build tools that I can reuse and will generalize. So that's kind of why I want to figure some of these issues out. Because, like, why, like, what happened here? Something changed here just in the last day that made this not work here. So let's take a look. Why would I be expecting to be able to union this? Oh. Let's see here. Oh, interesting. Yeah. Okay, this is interesting. There's something interesting going on here. Because we're constructing the head. Or no, we're not constructing the head. We're taking the head here, excluding these. Oh yeah, we're flattening this, splitting the components, and then triangulating caps on all of the... Yeah, okay, so something broke here. Let's see. Oops. Let's see what broke. So that's the neck. See, this actually is kind of automatically doing what I'm trying to do manually here. But the thing is that this is not, doing it in a way that looks good, because the purpose of this part of the code is to just create a manifold mesh that we can test. We can test the hair against as part of the process for creating hair. And what was this piece? What was that? Let's see here. Let's see. Let's factor this guy out. Because I don't know what that piece is. That piece is, I think, is what the problem is. I'm just trying to remember if I added something. Written face, the whites, irises. Yeah, what the heck is that? Let's just look at each of these. Let's see if we can find the culprit. So I'm using this very basic data structure that I have for hierarchy of parts, and it is just a dictionary of these kind of record types that hold things like the transformation, the part, and the name of the parent. It makes it very easy to iterate over things and look at what's going on. Face, the skull, that's like the back of the head. You got these eye parts. Interesting. Let's just take a look at how many components each of these have, because maybe one of them has some wacky component that I'm not seeing. Face 2. Oh yeah, there's the problem. I wonder, so I made this modification with the eyes. Oh, okay, I know what's going on. I know what's going on here. So I added backs to the eye holes. And it looks like what happened is a dimension that I wasn't expecting got added, and then when it got symmetrized, it created this separate connected component in the middle. Let's see if we can fix that. So something that I've added to a lot of these functions, this is a very big function for creating the whole head, and a lot of these functions now have a mode, which there are a couple different modes, like a standard mode and a print mode, so I can add special logic in for the case where I'm making something that I'm going to print. I'm not sure if that's the best way to do things, but you know, I'm trying to have this philosophy of making something once and then being able to use it for all these different applications. That's kind of like something that's integral to my project, so I don't think it seems like too bad of a thing to sort of bake that into some of this. So let's try to find the spot where we're doing this. Yeah, okay, so I'm wondering if why isn't the thing that I think it is here. Let's take a look at the see, let's see here, X, Y. Why is, so I was expecting this point to come straight back. Does that mean there? Oh, did I just, no? That is so weird. Because the blue axis is Z. That is weird, and we don't have another transformation here, so what's going on? This is odd. I don't know. It's an interesting little problem here. Okay, so we got points. So I did refactor this out, but this all seems to be working. faces. Let's take a look at... Oh, there we go. I forgot the axis equals 0 here. Yeah. Ah, yep, that's the problem. There we go. Okay, cool. That was an easy fix, and I think this should actually be a little bit farther back. Yeah. I need to go through and make all of these edges of the eyelid convex, the quads convex, and it's gonna bug me until I do that. Let's actually just do that now, just for kicks and giggles. Okay, so we've got gonna check Twitter just quick here, and I'll be back. I'm starting late, so I'm not really expecting too much interaction from my Twitter friends, but just checking. A few people have stopped by. Okay, so yeah, so we're going to be doing the same thing here. But with this, where's my... Oh, okay, yeah, this just defaults. I was wondering what was going on with that. So I've got... Yeah, okay. I had in my head that I made a function that did this, and then I was looking at some other code, couldn't find it. Oh, nice. Hey, Doug. Nice to see you here. Okay. Yeah, let's see if this does it. Okay, we gotta flip the order of these ribs here. And switch point start, point end. And actually I should... I should maybe double check. If I do that here, it's inner, so if I go inner to outer, get rid of the flip here, then I should be able to flip start and end like this. And that should do the same thing. And I'm going to check the original functionality. Oh, not quite. Oh, I'm going to check the original functionality and see if it ends up being convex. Because I don't... Sometimes these things end up kind of flip-flopping around. Yeah, no. See, it's not a matter of things being backwards because some of these are convex and some of them are concave. See these quads. Okay, so this new version is actually definitely better. We'll leave the old version in though. I need to revisit my loop bridging logic, and I need to revisit the application of that to this face stuff. It makes me feel good that I'm starting to use it here now. Because I actually wrote all of this face stuff without it, using kind of a complicated approach where I triangulate everything in 2D. Which you would still have to do with the new approach, probably, but okay, let's just pop up problems here. Okay, now this should solve our this should solve our union problem here. Because now we won't have that uh-oh. Interesting if this ends up being a giant sticking point. Oh, okay. I still have to... Okay, yeah. Because this is now... Because we swapped the order, now this is going to become point start. Jeez. Okay. Start. And start, and just check it both ways. Yeah. Okay, cool. And this is gonna be not nice, but still should, yeah, okay. Okay. Yeah, now we shouldn't have any weird issues here. Okay, so we're just gonna, in case we still run into issues, proxmesh is union. We should just run now through to the end without errors. Oops. And we're still viewing here. Get rid of that. Don't need to look at these anymore. Okay, cool. So that's working now. Okay, so what we have to do now is we have to solidify or turn some of these non-manifold, non-watertight meshes in the head into solid things. So we've got a list here. I'll disable the visualization. And when we run, and each time I run this, it's generating everything. It's kind of fun to think about that. So we've got the face, the skull, the whites of the eyes, the iris, the pupil, ears, eyebrows, and hair. So, let's start with the face and skull. I think those are going to be maybe the most annoying. And actually, just looking at this, I'm reminded of how easy it is to triangulate a boundary. So this should actually take care of it pretty easily here. So I think this is the last time we're modifying base mesh here, which is the face. So basically we need to just do this thing here. Base mesh equals mesh birds concatenate 0 faces, and then dot triangulate cap wait a second, why does this... Oh, yeah, okay. Dot birds. I'm gonna try to do this in a big expression. Graph dot find longest boundary of base mesh. And then as long as we process it, that should link everything. Actually, I don't think we even need to process it. And the interesting thing is, as far as I can tell, the slicer will kind of merge everything together. So we don't need to... There's a lot of like tricky things working with mesh Boolean operations and cutting and stuff that we don't have to worry about, because I know the final result of this is going to go into a slicer. So let's see here. This is base mesh. It's kind of a bummer we don't have semantic highlighting working over here. It's like it just doesn't work sometimes. It's too bad. Okay, yep. Perfect. Okay, and then we have our nice eyes. Yeah, see here. Basically before this, we have this open thing on the back that we're just closing up. And let's see here. Oh, interesting. Now this is triggering our union for the hair finding again. Ha! Weird. Let's just try processing. Let's see if that processes it. Oh, come on. I can't believe it. This is one. Oh. Oh. That's not good. That's not good at all. We're getting like some kind of weird double-sided thing there. Okay. I'm just trying to see if things are doubled up here. It looks like 22. Right? Because 1, 2, 3, 4, 5, 6. So are we coming back with... Are we coming back with extra faces? Just made this function. See, 20 faces. This looks like 20 faces. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so it's not getting doubled up here. That's good. Okay, so where is it getting doubled up? Are we finding a boundary? Because we shouldn't have any boundaries here at this point. Craft up. Find boundaries of base mesh. Zero. Okay. Oh. Is this... No, this should work just fine. Okay, so... Okay, so everything looks fine over on this side. So what is going on? Smash. Okay. Let's take a look here, I guess. Neck is one component. Face, one component. And let's take a look at the number of boundaries too. Something goofy is going on here. Yeah, we've got... Okay, so it must not actually be the face. It must be something else. Oh, snap. Okay. That's what's going on. Okay. I know what's going on. I know what's going on. Okay, new approach. So, what happened here is I think the fact that we introduced this face means some wonky stuff happens here when we do this merge. And then when we split components apart, we end up with kind of the same thing again. Where we have an empty... Which doesn't exactly... Doesn't exactly make sense, but I'm pretty sure that's the problem. Because we end up with... Yeah, we end up again with this with a hole. Actually, no. Yeah. Does... That's weird. That's odd. Looking at this, I can see that it would have failed, but I was not I was expecting it. I would have expected it to fail in a different way. Yeah, okay, yeah. This will do it, because we'll be able to see what's going on here. So the question is, yeah, somehow this is ending up as a separate piece after this join and split components, which I'm not sure why it's doing that. I would have expected it to end to it's kind of like a not a good situation mesh wise, but I wouldn't have expected it to become split, but that's okay. What we want to do actually is, instead of doing this, we want to just merge the I don't want to merge the face and skull here. Okay. Okay, here's what we're going to do for now. We're going to we're not going to do this. And then when we print, we'll join, we should be able to join the face and skull. I don't want to do it here because I want to be able to have these be separate parts for the I want to have them be separate parts for the game. Okay, so what else do we have left? So face and skull, there's some issues with just adding in that extra face that I don't want to deal with right now. Yeah, let's take a look at the whites and the irises. So the whites, we want to do something similar where if the oh, and we want to start. Yeah, we want to start point here too. There's a good chance too that a lot of this stuff is going to be too small to show up in the print, but I want to just go through the exercise of, oops, get rid of some of this stuff now. I want to go through the exercise of getting this right. Okay, so yeah, so what we want to do basically is we want to thicken these flat meshes out into 3D solids. And I think just rather than rewriting this logic, I want to get this done. So I'm going to just make a function called thicken that basically does what I did to, kind of what I did to the coat. So yeah. Okay. So let's see. And both of these are going to be, we're going to be thickening in the Y direction. So basically for every boundary so we'll just do positive and negative. So we'll translate the mesh forward by half the thickness, translate it backward by half the thickness, and then for each boundary we'll do a connecting loop that goes from the positive vertices to the negative, surface, and then we just got to concat everything together and process it because I'm lazy. And I don't I think if we can find the right ordering once, it should work. Oh, we've got to flip. We've got to flip this negative one. Yeah, okay, this is interesting. There's some interesting things we have to do here. So we have to flip. Yeah, we have to flip the faces of this one. Faces. And then I think once we find the right orientation just once, it should work. It should generalize to anything because the orientations should be consistent. So let's see. Okay, so there's our iris. Oh no. I can't believe this. This is every single one of these things that I do gonna trip up my hair finding logic. Over crying out loud. What's wrong with this? Oh, come on. Okay, we'll come back to this. This house somehow also tripped up the logic. Okay. Bizarre. Something weird is going on. Okay. But let's keep our focus here. So we just want to thicken this now. Iris mesh equals thicken Y, and we'll just say that amount. Yep, okay. That looks like what I expected. We just got to reverse the orientation of these guys. Now you can see we have a little bit of an edge there. That's actually probably a little bit too big, so let's bring that down. Okay, and that's not a problem for the hair cutting thing, whatever. Man. Okay. And then same kind of thing we're going to do with the pupil here. And this will only be shared print. See, that looks exactly like I wanted it to. So why? What the heck is going on with the white? What is the problem with this? Oh, what? Did that just work now? I'm so confused. Something goofy is going on. Yeah, okay. We're gonna solve this problem first and then we'll come back. So there's something here going on with how we're doing this white that is throwing off our... This looks fine. Okay, so got one component and 0 boundaries. So what's the problem? Okay. I'm gonna add a little check here. If not diff dot check tight. This is crazy. It's crazy. So the problem appears to be that something strange is going on here that is causing this mesh to show up as watertight, but not the Boolean operation library doesn't like it as a volume, which is strange. I would say usually that does not happen. Let me just something here. Let's just try this. We're just trying to see if I can actually check which thing is not manifold. Let's just insert this code right in here. It's a little check for meshes. Mesh manifold is I have my own mesh. And then let's see if we can assert something here. Like, first of all, does this work? I'm assuming it does. So let's just check. Do we have like it is status? Let's see if status. Okay, so there's two here that are not manifold that it's complaining about. Let's see. Which those are. So if mesh manifold dot status equals manifold 3D dot error dot not manifold, Ah! I wonder if, because these were like completely contained by I wonder. Oh, jeez. Okay. Stop that. I wonder. It's odd to me. It's odd to me that these issues crop up now, but it's like, I think what's going on is because I am adding. Yeah, that's it. It's more issues that show up now because we are like doing this concatenate and then separate into it's this operation. I think that's the problem. Because this thing does not do what you think. Doesn't behave think with edges that connect to more than two faces. I think that's the problem, because what's happening here is we're ending up with these things that aren't what you'd expect, because this is it's like we have the white, and then we have the center of the white is getting attached to this thing, the back of this thing. Here, let's get everything else turned off here. It really annoys me that these colors don't match in Polyscope. I need to figure that out, because see, here's the problem. This one down. This is supposed to go with this, but because there's this, instead of when we do the split components, they're getting swapped, right? Instead of the iris or the pupil part being a separate part, and this it's all getting split. So it's like, or maybe it's actually, what's probably going on is it's not split components. It is the process no validate that's doing that, because this is just pure face adjacency. So this is the process no validate. It's not, yeah, it is changing the connectivity of faces. Faces where an edge connects to more than two faces. Okay, and that's why the problem goes away when we're doing all of it. So and this we can make this all just false for now. The problem isn't things being watertight. This should make things watertight. Because watertight, I don't think depends on the actual positions of vertices. It depends on the connectivity. And there's no reason for this to fail at that. Okay, let's just make sure we get the same issue here. Okay, now if we go back to our human head and turn this stuff back on. Yeah. Because see, now we don't have this weird, we don't have these situations where we don't have these situations where we have multiple vertices that are going to get joined. We have a separation. Okay. All right. So look at this now. We've got our face and skull. And then we have just the ears and eyebrows. So now that we have thicken, the rest of these should be, the ears and eyebrows should be easy at least. Okay, so eyebrows, eyebrow mesh, project onto face, translate parts. If mode equals shared print eyebrow mesh, and let's see here. We'll just say idim times 8. Or idim times 4. Yep. Too thick. Yeah. There we go. All right, so ears. Offsets. Parts. These are being translated. Are we already? Yeah, they're already rotated. All right. Well, let's add a mode to our ear. So this should be axis aligned now. It's on X. So mode equals share dot mode print. I think we'll just do the easy thing, rotate it out, thicken in Y, rotate it back. Thicken Y, and we can use height divided by 8. Take back. So, and then we'll just pop this in here. Eventually we can model something a little bit nicer, but the point here is to get started and then see what actually makes sense. What actually makes sense to do. So I think we can go a little bit. Well, that's the same thing. We can go a little bit narrower. We can even do something like fan it out, you know. Okay, so just the face, skull, and hair. So, yeah, the face and skull, I'm going to probably work on that, because that logic is going to be a little bit more fiddly. I'll work on that offline, but let's try to get the hair. So, okay, so we've got our female hair. Let's get rid of these guys. So right at the tail end here, we've got our hair, and I think I've just got to add a point somewhere, just like in here, that these all can connect to. And then the question is, will it be manifold? But yeah, I guess we'll see. So let's say center equals one graph dot find still I have a find long. Yeah, that's just a equals hair converts equals hair. Okay, and then the center That's strange. Yeah, see, that's right. So what gives here? Extend from cap to new vertices. Trying to use this old function that I haven't used a whole lot lately to do this, because it's kind of the cleanest way to do what I'm picturing in my head, but it's not working. I've got something going on here that I don't remember. I'm getting goofy sizes here, but it seems fine. Derp. Okay, and this looks like it's gonna be manifold, so I think we're gonna be okay. I'm gonna add a mode here. Mode. And if mode equals shared dot mode print. Whoops. Where equals Yep. Okay, just the face and skull. Let's actually... Let me just check how long we've been going. I might just try to do this on stream. 11:45. We've been going an hour and a half. I think we can do this. So what we're trying to do basically is, the reason we want these to be non-watertight is because we want to apply these cutters, and that's generally not going to work if we have stuff that's not watertight. Let's just see. Actually, let's just look and see how this. That looks a little derpy, but I can fiddle with that. I can fiddle with that later. Yeah, it's complaining that this isn't watertight and that's not watertight. So what we can just do is, in here we can just merge those two. So let's just do that. And the easiest way to do that is just going to be to pull out the skull right? So I'm going to merge face and skull here. So skull equals parts. Let's just clean this up a little bit. So skull is parts. Prefix. So we want prefix, head, skull, and we want to skull key, delete skull key out, and then we want to have face key, because it's head face, then face is parts, face key, face dot model equals mu dot process validate mu dot cat of face dot models skull dot model. And actually, let's just visualize this just to make sure it looks like we expect. Oops. What? Oh, that's dumb. Prefix. I'm not going to fix this right now, but I'm breaking my conventions about how I use the word prefix for parts here. Oh man, that's horrible. Well, that might explain some problems that I was having the other day. some of these are failing. Stuff is failing against the coat, so that tells me that I didn't, like, my coat mesh is not right. And this all this head stuff seems to be working now, so that's good. We can get rid of this, and that this get rid of now. We made really great progress here. It's nice when you're done with the things that not all meshes are volumes. Okay, so we're this coat evidently. Oh, okay. This is really simple. This is a really simple fix. Here we go. Here we go. Yeah, I just forgot to flip the faces on the inside of the coat. Okay, so torso mode equals mode print. Res inner. We just have to flip the faces. Come on, here we go. Flip faces, res inner. Whoops. Typo. Yes. Okay. Now, we've got to exclude the arms from the pelvis cutters. But this is exactly what I was hoping to see, right? So we're cutting through multiple meshes. This Z-fighting stuff is not a problem. I want to add some additional logic up here because this is kind of a mess, but overall this looks like what I wanted to see, and you can see how this is making that kind of cutout that we would need to have pivoting legs. And actually, let me see if I can just exclude the arms and sleeves quick. We're so close. I don't want to stay up too late tonight, but we're so close. And what we can actually do, because I'm just tossing everything in here at once. So we're gonna do two areas. So we'll do leg cut names and arm cut names. So names to cut. So we'll call this region cut names. Oh, I like this song. It's a good one to take us home. So arm const arm cut names. Actually, arms, legs. this should just do it in 2 steps. Arms, legs. Okay. So now when we do, we can do this better later. But basically, if we can actually just look and see the names to cut here. So when we're doing arms, we're cutting these things. Okay, when we are doing legs, we want to exclude anything that has arm or sleeve in it, right? So if region equals legs, then we're going to filter exclude arms, hands, sleeves. So names to cut equals X for X in names to cut if you can't do starts with here, so we have to do if arm not in X or hand not in X or X, and it's actually and hand not in X and sleeve. And just to be better safe than sorry, just add some parentheses. Oops. Okay. And just cut. Okay. Here we go. Arms. Legs. Boom. All right. Just gonna do one more thing. This isn't gonna quite work because clothes aren't gonna be parented to limbs, but I just want to see what things look like in Blender. And did I exclude the pivots somehow? Yeah, because they're not in cutters. So like if I grab the actual leg, delete those and see like what I want to do actually here. What I want to do too is like basically if I separate this into parts, we can kind of, like, I just want to get rid of this stuff, right? So we end up having like a flat surface here. And we go into like if we grab nice. Yeah. I don't know the hotkey to set the pivot, but like this should basically have the same oh yeah, and then we'll want to split this down the back too. But like this should have the same pivot as the thighs, right? So it can pivot up. Cool. All right. Well, this was a great success. Definitely some things that need to be tweaked here, but like the basic idea of having these, obviously a lot of stuff needs to be tweaked, but the basic idea of having these things be cut and like transformed into something printable is working. And I can go to sleep now and look forward to trying to actually part things out, group parts, add pivots, and print this tomorrow. So thanks for everyone who watched. Thanks Doug for hanging out, and see everybody next time.